7, 10, 9. We have ignition sequence start.
BBM, go.
To understand a part of something, the closer look may be the better look. But to understand the whole of something, the better look may well be the look from farther away. Only when a spacecraft could carry a camera far enough out into space did we get our first view of the Earth as a planet. In 1972, a satellite was launched specifically to record images of large areas of the Earth from an orbit 910 kilometers away. Landsat, the Earth Resources Satellite. Geologists welcome Landsat's big views from space as a new way to study large areas of the Earth's crust. Satellite images are providing complete, detailed views of faults in the Earth's crust. These cracks in the surface may run for hundreds of kilometers, but they're not easy to detect and trace. Landsat images, 185 kilometers on each side, offer geologists an exciting new view of these important Earth fractures. Geologists study faults in the Earth's crust, such as this view of part of California's San Andreas fault system, for many reasons. One important reason is earthquakes. This diagram shows an earthquake-prone fault in the Earth's crust. Great pressures from deep inside the Earth can begin to press on one side of the fault. On the other side, the Earth begins to slip, to move, and then suddenly shifts. There's an earthquake-prone fault in the state of California, a huge fracture more than 1,000 kilometers long, the San Andreas fault system, consisting of many smaller faults like this recent break. Hundreds of earthquakes have occurred along this fault and the smaller faults that branch off of it. Landsat images of the geological fault systems in California have given scientists a new and valuable perspective on this threat of earthquakes to the population of this region. Views like this, combined with many other kinds of data, will help scientists monitor the San Andreas fault system. Knowing exactly where the faults lie should help to determine where not to build a town, a nuclear power plant, or recreational mountain resort. Landsat images can be used to revise and correct the geologic maps of all areas of the Earth where earthquakes occur. Fractures in the Earth's crust are related to more than hazards like volcanoes and earthquakes. They're the pathways through which minerals travel upward from the depths of the Earth. Minerals begin as solutions containing chemical elements far below the Earth's surface. High temperatures form bodies of magma or molten rock. Mineralizing liquids from these bodies of magma move through faults and fractures, diagrammed here in yellow. Along the way, the rising liquids interact with rocks in the crust and gradually form minerals. Iron, gold, lead, copper, silver, all of the many ores which are precious hidden resources. Iron is often present when other minerals are formed, and just as anything which contains iron will rust when left exposed to air and moisture, rocks which contain iron show a color change when they're exposed on the Earth's surface. This discoloration was a clue to possible mineral deposits which early prospectors would search for. Early gold hunters would also look near streams, probably without ever knowing that streams follow fractures, and fractures are likely to have ore deposits nearby. In their search, these prospectors had a little knowledge, hunches, and prayers. Most found disappointment. A few found gold. As the years have passed, and the easy-to-find surface deposits of gold and other ores have been exhausted, geologists have had to look harder and more scientifically for new deposits, probing deep into earth fractures for the treasure. Modern technology can remove ores from deep in the earth, and every known deposit is drilled, exploded, and dug to produce its maximum yield. Minerals are a non-renewable resource, harder and harder to find at a time when the world's growing population demands more and more mineral resources for manufactured products and energy. One of the challenges facing geologists today is to find scarce new mineral deposits. The launching of Landsat in 1972 began a new era for geologists involved in this urgent search. This is a Landsat map of the entire United States, a mosaic of many overlapping Landsat images pieced smoothly together. This new total view reveals to the eye of a trained geologist the subtle indications of entire fault systems which were previously undetected. For example, many gold, silver, silver, and copper mines in the state of Nevada are found along a fracture called the Midas Trench. The Midas Trench is shown here by arrows, placed along the fracture on this Landsat image. Since minerals most often develop along fault lines, Landsat faults provides modern-day prospectors with valuable clues as they explore new areas. Landsat imagery can provide another hint to people trying to decide where to begin prospecting operations. When Landsat images are processed on a computer, areas with surface iron oxide discoloration can be clearly distinguished from surrounding areas by displaying them in a separate color. For example, green. This surface discoloration can be a sign of mineralization. This is a Landsat image of a well-known mining area in Nevada. When the locations of known mines are placed over the Landsat image, they match the areas of the iron oxide discoloration. In exploring new areas for minerals, Landsat maps which show fractures and discolorations are a useful first step in showing prospectors where to begin work with other exploration techniques. Landsat can't find the buried treasure, but it can help point the way. Landsat's remote sensing view and its continuing repetitive coverage of the same area can also record changes in the Earth's land masses. At the bottom of this Landsat mosaic of Iceland is the small island of Ames, an island with a volcano which had shown no activity for years. In 1973, that changed. The volcano suddenly erupted. For 6 weeks, the volcano roared, raining fiery volcanic ash down on the town. The air filled with poisonous gases belched out of the volcano. The people were all evacuated, and much of the town was destroyed as waves of red-hot lava poured through the streets and on into the sea. By the time the volcano was spent, lava pouring into the sea and solidifying had added 2½ square kilometers to the size of the island. A reminder that this entire island was once formed by volcanic lava bursting out from beneath the ocean floor. The new 2½ square kilometers of land were recorded clearly on this Landsat image, showing scientists how the satellite can be used to map landmass changes in the most remote areas of the Earth. Landsat's remote sensing provides us a view from outer space which helps us to better understand our dynamic and ever-changing planet.